So let's take a look at this sum and difference problem. Let's say that we were given that the sine of alpha is equal to 5 over 13, and alpha is between negative 3 pi over 2 and pi. And negative pi. So that's a little tricky there. They're trying to kind of throw you off a little bit, making sure you understand how negative angle measures work. We'll look at that in a second. And we're also given that the tangent of beta is equal to negative square root of 3, where beta is greater than pi over 2 and less than pi. So we're going to work out the sum and difference of sine and cosine, and then we're going to do the sum for cosine, and we're going to do the difference for tangent. So we need those formulas to require us to figure out, we have the sine of alpha, we're going to need to find the cosine of alpha and the tangent of alpha. And then we were given the tangent of beta, so we're going to need to figure out the sine of beta and the cosine of beta. So we need sine, cosine, and tangent for alpha and for beta, and then we plug everything into our formulas. Let's start with alpha, and let's figure out the cosine of alpha and the tangent of alpha. So we need to figure out x, y, and r for alpha. The first thing you need to do is figure out which quadrant is this in. So negative 3 pi over 2, so alpha is greater than that and it's less than negative pi. If this is 0 and we go we go clockwise, this would be negative pi over 2, and this would be negative pi. This would be negative 3 pi over 2. So if alpha is greater than negative 3 pi over 2 and less than negative pi, then it's got to be here in the second quadrant. The reason why that's important is when we do figure out these other angle measures evaluated at alpha, we're going to need to know, do we need our x's positive, do we need our x's negative, do we need our y's positive, do we need our y's negative. So if we are in this second quadrant here, remember when you solve for x and y that your x will always be negative and your y will always be positive. Okay, so if we want to figure out the cosine of alpha, we need x divided by r, and if we want to figure out the tangent of alpha, we need y divided by x. We were given in the problem that the sine of alpha is equal to 5 over 13. So if we know that, we also know that sine is y over r. So we have what y is equal to. It's equal to a positive 5. R is equal to a positive 13. We need to figure out x because we need that for both of these other trig functions. So use your formula x squared plus y squared equals r squared and solve for x. So if y is 5 and r is 13, I have x squared plus 13 squared equals 5 squared. Is that right? I need to wake up. Wake up. Alright. X squared plus 5 squared equals 13 squared. Alright, so make sure you plug in everything in the right place. Now, so that'll give us x squared plus 25 equals 169. So x squared equals 144. So if you took the square root of both sides, you would get plus or minus 12. Since we're in the second quadrant, the x's are negative. So x needs to be negative 12. Alright, so let's come back over here to our formulas. Cosine of alpha is x over r, so that's going to be negative 12 over 13. Tangent of alpha is y over x, so that's going to be positive 5 over negative 12. So you can say that's like negative 5/12. Alright, so we have solved for cosine of alpha and tangent of alpha. We'll need to plug those into our formulas. Whenever you're doing all this work, especially with me, I'm not the neatest person in the world, so it may be in your best interest to like highlight the answers beside the trig functions. I know you probably don't carry around a highlighter, but if you do, that's an option. If not, you might want to underline it just so you can pick it out of all this work for when you plug it in your formulas. Alright, so we have dealt with alpha. Now let's work with beta. Alright, we're given that the tangent of beta is equal to negative square root of 3. And beta is greater than pi over 2, so it's greater than pi over 2, less than pi. So we're in that same quadrant for beta, where the x's are negative and the y's are positive. So we're going to want to find the sine of beta and the cosine of beta. And remember, sine is y over r, cosine is x over r. Tangent here is negative square root of 3, and that's y over x. Now, where does that negative come from, the y or the x? The x, because we're in the second quadrant. So y is equal to a positive square root of 3, x is equal to a negative 1. So that's a little tricky there. We need to figure out r to solve these other two. So we say x squared plus y squared equals r squared, or negative 1 squared plus square root of 3 squared equals r squared. So 1 plus 3 equals r squared. 4 equals r squared. R is a radius, so it can't be negative. So r is going to be positive 2. Alright, sine is y over r, so that's going to be the square root of 3 over 2. Cosine is x over r, that's going to be negative 1 over 2. Alright, so now we have solved for the sine, cosine, and tangent of alpha and of beta. That's what I need for my formulas. So let's start out and let's do the sum for sine. The sine of alpha plus beta. The sine of alpha plus beta equals the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. So let's plug those values in. Sine of alpha is 5 over 13. The cosine of beta is negative 1/2. Cosine of alpha is negative 12 over 13. And the sine of beta is the square root of 3 over 2. Alright, so now let's go through and see if we can put these two fractions together. That's going to be a negative 5 over 26. And that's going to be a negative 12 square roots of 3 over 26. Now, we do have a common denominator. These two terms in the numerators are not like terms. So the best way to write your final answer would be negative 5 minus 12 square roots of 3 all over 26. That would be your most correct answer. I would think that's what your homework would be looking for. Or the answer that would be listed on a test if this was a test question. Alright, let's go with the difference for sine. The difference for sine is very similar. That's why I want to go ahead and do it now. The only thing that changes with the difference formula is that instead of a plus, we have a minus. So all the work stays the same, except you have a minus right here instead. So it's going to be negative 5 over the square root of 6. If you had an extra minus right here, that would become a plus. So plus 12 square roots of 3 over 26. So you can write that as negative 5 plus 12 square roots of 3. Again, the only thing that changes is the minus. The plus here becomes a minus. It was a minus when I was working it out because of the way things multiplied out. So if I put another minus there, it'll become a plus. That would be my answer. Alright, now let's do the sum for cosine. So we need to look back at our formulas or remember these formulas. the cosine of alpha plus beta is equal to cosine of alpha times the cosine of beta minus, now remember with the sum, you put a minus with cosine. So minus sine alpha sine beta. So let's take and plug these values in. So I'm going to have negative 12 over 13, that's cosine of alpha, times cosine of beta. Cosine of beta is a negative 1/2, minus sine of alpha is 5 over 13, times sine of beta is square root of 3 over 2. Alright, so that's going to give me positive 12 over 26 minus 5 square roots of 3 over 26, or 12 minus 5 square roots of 3 all over 26. Alright. The last sum and difference we're going to work, let's try the difference for tangent. Alright, the tangent of alpha minus beta. So the tangent of alpha minus beta in the formula, when we have a minus right here, we have a minus in our numerator in the formula. So it's tangent alpha minus tangent beta over 1. Alright, when you have a minus here, you have a plus in the denominator. So it's plus tangent alpha times tangent beta. Alright, so let's plug in our values. Let's see, tangent of alpha is negative 5 over 12. Tangent of beta is negative square root of 3, so it's minus negative square root of 3 over 1 plus, and then tangent of alpha is negative 5 over 12. Tangent of beta is negative square root of 3. Alright, so I'm going to clean up some of these positive and negative signs real quick, and then we'll decide what's the best way to write our answer. So you can see that it's definitely not very clean here. We have fractions within fractions. Alright, we have a fraction in the numerator, a fraction in the denominator. The good thing is it's the same number in the denominator of each one of these extra fractions we have. So that means if I multiply the numerator and denominator by 12, that's going to get rid of this fraction here. So that's the first thing I would do. So this is going to be 5 plus 12 square roots of 3 over 12 plus 5 square roots of 3. Yes.
Where did the negative on the negative half plus come from? Where did it go?
Oh, this negative right here? Alright, yeah. Sorry. Alright. So, now that I have this rewritten without any fractions, my next problem that I have with this answer is that we have a radical in the denominator. So what you need to do is multiply the numerator and denominator by the conjugate of the denominator. So same two numbers, change the sign in between them. Now I need to multiply everything out. Alright, so once we multiply our numerators together, you want to FOIL that out. Let's see, we're going to get negative 60 plus 25 square roots of 3 plus 144 square roots of 3 minus, and now that's going to be 60 times 3, so that's 180, and that's all over 144 minus 75. Alright, when you multiply conjugates together, you can use a shortcut. You don't have to FOIL it out all the way. You say the first terms times each other and the last terms times each other. Alright, so it's going to give me negative 240 plus 169 square roots of 3 over 144 minus 75 is what? 25 and 44.